Basics of decimals. So before we work with decimals, we have to remember our place values. And the place values are simply, if we have our decimal point, we have our tenths place, our hundredths, our thousandths, the 10,000ths, 100,000ths, etc. And to the left of the decimal place, we have our ones place, our tens place, our hundreds place, etc. So what's happening is, as we move from left to right down the number line, we're dividing by a factor of 10, dividing by a factor of 10, dividing by a factor of 10. So if we had the number 42, this is equivalent to saying we have 4 tens and 2 ones, or 40 plus 2. So when we work with decimal numbers, we use the same principle. If I say, just back to that 42, where we say 4 tens for a value of 40 and 2 ones for a value of 2, if I need to take 3 tenths and put it into decimal format, well, we look and say, well, where's our tenths place? Our tenths place is directly to the right of the decimal point, because it's our whole number divided by 10. So 3 tenths is 0.3. The 3, because this is in our tenths place. So it's saying we have 3 things in that tenths place. Just as if we have 40, it says we have 4 in the tens place for 40. Here we have 3 in the tenths place for 3 tenths. So if I needed to write 5 hundredths as a decimal, we don't have any whole numbers, so we put the 0. And then we have our tens place, our hundreds place. The 5 is in our hundreds place, and we use a placeholder of 0. And that's simply saying we have 5 hundredths. Notice that we do put the 0 out front. This is particularly important. In healthcare, zeros lead. They never follow. So we are always going to have a 0 in front of our decimal point, because it's too easy for somebody to miss a decimal point when they're reading. If you're reading a medical chart, and we know that not everybody writes 100% legible when we're talking with charts. So we always put our leading 0. Decimals are just like fractions. They show a portion of a number. So decimals have a value of less than 1 if there's no whole number. But I want to talk about rounding decimals. Right? So rounding is helpful for mental math, but it can create many errors when we are doing actual dosage calculations. So we're going to talk a lot about our rounding as we move on, and what I'm going to say repeatedly is we never want to round when we're doing problems with multiple steps until the end. But if I needed to take the number 603 and 95 hundredths, and I wanted to round to the tenths place, what we're going to do is we're going to look at the number, identify the tenths place. Right? So this is our tenths place. So we want our number to truncate or stop here. So we look at the number that's smaller, which is a 5. Remember our rules of rounding. If it's 5 or above, we round up. If it's 5 or below, we round down. So rounding this to the tenths place, actually says that we would round this to 603, but then we have 10. So if we round to the tenths place, we actually round it up to 604. You know, it's a little confusing because of the whole number, but if we said we were going to round this up to 603 and 10 tenths, right, because rounding 9 up gives us 10. Well, look, 10 over 10 is simply 1. So we have 603 plus 1, 604. So this is a little bit of a tricky question. But let's say we have 602 and 467 thousandths, and we wanted to round it to the tenths place. We look at our tenths place, we identify one place to the right, and we notice that 6 is greater than 5, so we're going to round up. When we round up to the tenths place, right, we're rounding to the tenth, so the tenths is going to be the last number. We're at 602.5. If we need to compare decimals, we can do it place by place. So if I have the decimal that looks like this is our tenths, hundredths, thousandths, 10,000ths, so 685 10,000ths, and we have the decimal, this is in the tenths, hundred thousandths, so 684 thousandths, and we wanted to compare them, find out which one is larger. We simply just work left to right, place value by place value. So we see that the zeros are the same. We can't compare. When we come to our tenths place, well, this 6 is larger. Because the 6 is larger, we don't have to go any more. 684 thousandths is the larger fraction. So you ask, how do I know that it's 684 thousandths? Well, the nice thing about working with fractions is that they follow our place value system really nicely. So it's really easy to go back and forth between a fraction and a decimal. Right here we have 0.45, but we don't read it as 0.45. It's not mathematical. So we want to look and say, well, our rightmost significant digit, or that rightmost digit, is in what place? Well, it's in our hundredths place. Right? Hundredths place. So that means if we need to write this as a fraction, our denominator is going to be 100. The numerator is simply everything to the right of the decimal point. So we can write 45 hundredths, the decimal, as a fraction 45 over 100. We check 45 is less than 100, so we have a proper fraction. That makes sense because we know that 45 hundredths, the decimal, is less than 1. But of course this isn't simplified because there are common factors between the numerator and the denominator. So both numbers have a common factor of 5. I can factor a 5 out of 45, I'm left with 9. And I can factor a 5 out of 100, I'm left with 20. So our simplified fraction is 9/20. And there are no common factors between 9 and 20. All right. Let's try some other decimal questions. In class, we talked about looking at the syringes. So please refer to the lecture videos that have been posted previously or your slide notes about the syringes. But let's talk about adding, and for that matter, subtracting fractions, because they follow the same rules. And I keep writing on a slant. I apologize. So if we have the decimals 13 and 72 hundredths plus 1 1,000ths plus 20 and 54 hundredths. So notice each time I do this, when we have the decimal point, that implies the word and. It tells us that we have a portion of something. So when we're going to add decimals, we need to line the decimal points up. So I'm going to rewrite these so that they're vertical. 13 and 72 hundredths. 1 1,000ths. So we want all of our places to line up. 254 hundredths. So what we notice is that we don't necessarily have numbers in every place. So for our purposes, just to keep things lined up, it's okay to add some trailing zeros here when we're doing the work. That way we know everything lines up and everything gets carried out to the thousandths place. When we add, the first thing you want to do is drop your decimal point down. Just bring the decimal point right down directly under the numbers. And we add as normal. 0 plus 1 plus 0 is 1. 2 plus 0 plus 4 is 6. 7 plus 5 is 12. So we have our 2/10. Carry the 1. 1 plus 3 plus 0 plus 0 is 4. 1 plus 0 is 1. And then we have our 0 plus 0 plus 2 is 214. So we have 214 and 261 thousandths. If we needed to write this as a mixed number, we could very easily do that. Our whole number is the 214. The proper fraction, the numerator is 261. The denominator is tenths, hundredths, thousandths. So 261 over 1,000. We know that this can't be reduced because 261 is not divisible by 10 or by 5. The same principle works if you want to subtract. You subtract your decimals, line up the decimal point. So if we wanted to take 4 and 27 hundredths and subtract 25, we could easily do this. So 4 and 27 hundredths, lining it up vertically. We're subtracting 25. I'm going to add our zeros. But notice what happened here. If we're going to go subtract, we know that we're going to have some negative values. So don't forget that you could very easily say that this is the same as 4 and 27 hundredths plus the opposite of negative, or plus the opposite of 25, which is 25. And when we do this, remember we're adding, we determine the sign of the number with the largest absolute value is 25. So that means our sign is going to be negative. We can just throw that in there. Find the difference between the absolute values. So when we line it up, I'm going to add my extra zeros for placeholders, and we're going to subtract. We can't take 7 away from 0, we can't take 2, we can't use anything here. So we have our 4. We're going to borrow again from here, so I can just throw my 9 there, and 10. 10 minus 7 is 3. 9 minus 2 is 7. The decimal point just gets dropped down. 4 minus 4 is 0. 2 minus 0 is 2. So our answer is, just put it all nice and together, 20 and 73 hundredths. When we start working with multiplication, I don't want to say it's more difficult, but the rules are just a little bit different. So when we multiply decimals, we have to be careful of our decimal places. So if I wanted to take 3/10 and multiply it by 4/10, just want to show what's happening here. If I said that wrote this as a fraction, 3/10, because it's in our tens place, times 4/10, because the 4 is in our tens place. Remember, multiplying fractions, we multiply across, so we're left with 12 over 100. Well, if we wanted to now take 12 over 100 and put it into a decimal, well, we've got to go out to our tenths hundredths place. So we're at 0.12, 12 hundredths as a decimal. So this number has 1 decimal place, and this number has 1 decimal place, but our product has 2 decimal places. So the reason for that is because, remember, when we're multiplying fractions, we have to multiply the denominator straight across. So if we were going to carry this out as a regular multiplication problem, instead of turning them into fractions first, we notice that this has 1 decimal place, this has 1 decimal place. Or we could say, well, this is our tenths place, this is in our tenths place. So we're going to do the multiplication as normal. 4 times 3 is 12, carry the 1. 4 times 0 is 0, bring down your 1. But because we have a tenth and a tenth, this tells us that our answer is going to be carried out to 2 decimal places, or we're going to have 1/100ths, because 1/10 times 1/10 is 1/100th. So 0 and 12 hundredths. So if we have 45 hundredths times 2/10, 45 over 100 times 2/10, we're left with 90 thousandths. 100 times 10 is 1,000. So leading 0, tens place, hundreds place, thousands place. But take a look here. Remember, zeros lead, they never follow. So we don't actually need this 0 in here. And sure enough, if we look at our fraction, we can factor out a 10, factor out a 10, we're left with 9 hundredths. To see the decimal multiplication, two times 5 is 10, carry your 1. 2 times 4 is 8, plus your 1 is 9. The rest is 0. We've got 2 decimal places, 1 decimal place, so we need 1, 2, 3 in our answer. But again, 0.090 is the same thing as 0.09. And in healthcare, we're not going to have that leading 0. So it is just 9 hundredths. Dividing fractions by a whole number is pretty straightforward. If we need to take 25 hundredths and divide by 5. We can set this up into our long division. Our numerator in divided by 5. We're going to put our decimal point right above, so it just comes right up. 5 doesn't go into 0. 5 doesn't go into 2, but 5 goes into 25 5 times. Twenty-five hundredths divided by 5 is 5 hundredths. What we also could have done is we could have made these both whole numbers. In order to make 25 hundredths into a whole number, we multiply by 100. If you multiply the numerator by 100, you multiply the denominator by 100. So we have 25 over 500. If we think about, you could think about quarters and how many quarters do you have in $5, or notice that 25 and 500 have a common factor of 5. So you're left with 5 over 100. 5 over 100 both have a common factor of 5, and we simplify to 1/20th. So thinking, hey, 1/20th, is that really equal to 5 hundredths? So we come back and refer to our fractions, or excuse me, our proportions, and we ask ourselves, is 1/20th equal to 5 over 100? So you can check by cross multiplying. 1 times 100. Ask yourself, does that equal 20 times 5? Sure enough, 100 equals 100, so they are equivalent. 1/20th is simply 5 hundredths reduced.